So we have spectrochemical series will dictate about the strength of the ligand, students. Strength of the ligand will be spoken by spectrochemical series, or it is an arrangement of the ligands in the increasing order of their strength. Arrangement of the ligands in an increasing order of their strength. That is, we have two types of ligands in general. We have weak field ligands and strong field ligands. One of the important clue I can give you here is, remember, whenever oxygen is a ligand, oxygen and halogens are the ligating atoms. When the coordination bond happens between the metal ion and the ligand, through the involvement of the oxygen or the halogen as the ligating atoms, generally they will be having a weak field. Got it? So then generally they will be weak field ligands or they are weak ligands. So very simple one. Whenever nitrogen and carbon is involved, remember they are strong field ligands. This is a simple clue for you. Strong field ligands. In specific, I can say nitrogen and the carbon are having strong field ligands. Carbon is greater than nitrogen. Halogens, oxygen is greater than the halogens. Are you getting the clue now? Very simple one. Very, very simple. Just keep it in mind. This rough idea is enough for you for predicting number of things regarding the ligands. That is, you don't have to by heart everything. That is, oxygen, that means halogens comes first or halide ion comes first. Then generally the oxygen comes, then the nitrogen comes, then the carbon comes. I mean, this will be the general order. There will be smaller variations, doesn't matter. In general, we can put it like this. Or in other words, the spectrochemical series speaks about the strength of the ligand. There are two classes of ligands. One is weak ligand, another one is a strong ligand. Generally, weak ligands are the one in which the coordinating atom is either oxygen or the halogen. Strong ligands, the coordinating atoms are nitrogen or the carbon. In specific, I can say that oxygen containing ligands are little stronger than the halogen containing ligands, and carbon containing ligands are stronger than the nitrogen containing ligands. That means among the strong ligand, nitrogen containing ligands are weaker ligand. Among the weaker ligand, the halogen containing ligands are weakest ones. So roughly I can put it, the common ligands whatever we are using, I can put the spectrochemical series like this. I minus is least, then comes Br minus, then comes Cl minus, then comes F minus. Right? Roughly. That is whatever the general ligands will be employing. There are other ligands also. Then we have OH minus. Then you can put water. Right? Then you can have nitrogen containing ligands. You can start putting here. Ammonia you can have. Ethylene diamine you can have. Ammonia which is equal to pyridine. You can put it. Then you can have ethylene diamine. In between here you have a tetras, CH3CO minus, oxalate ions and all comes here. After that water comes, right? CH3CO minus, oxalate and all comes. So you can have, the NO2 minus can be having, the triphenyl phosphine you can put it here, cyanide can be placed here, CO can be placed here, and so on and so forth. I am putting the general ligands, students. In general, you should have a rough idea. These are strong ligands for you. This is the nitrogen is the binding atom here, not the oxygen. If oxygen is there, then it goes here. So from here onwards, we will have a strong ligands. I can divide the spectrochemical series into two parts. This part is the strong ligand part, and this part is our weak ligand part. This part is our weak ligands part, and this part is our strong ligands part, right? Strong ligands part. Very clear? So this part is weak ligand, this part is a strong ligand part. Or in other words, what I mean to say is, this will have a low spin complex, this will have a high spin complex. The electrons get paired when the ligands are this, electrons will not be paired when the ligands are this. That we will take care afterwards. And one more thing has to be remembered. See, this is, oxygen is not the binding atom, carbon is the binding atom. Right? Carbon is the binding atom, carbon is the binding atom, nitrogen is the binding atom, ethylene diamine nitrogen is the binding atom, nitrogen. So that means nitrogen and the carbon, if coordinated, it will be a strong field. Oxygen and the halogens coordinated, it will be a weak field ligand. Among the nitrogen and the carbon, so the carbon containing coordinating ligand will be strongest. We will take care of those things. In specific, we will take care afterwards. This is about the ligand, student. About the metal ion. So metal ion, always remember 3D is less. Then comes 4D, then comes 5D. That means 4D and 5D, central metal ion doesn't need strong ligand. Does not need strong ligand. Strong ligands. Right? Doesn't need. Keep it in mind. Next one is geometry. I am talking about geometry. See, geometry, octahedral is greater than the tetrahedral. Octahedral is greater than the tetrahedral. That means, what it means to say that it matters for octahedral complexes only, it matters whether you are having a weak ligand or the strong ligand. But for the tetrahedral complex, whether it is strong or weak, will most of the time will give you a high spin complex. Because, why? Because tetrahedral complex is having only 4 ligands. Right? One another thing is octahedral complex is having 6 ligands. So the ligand field is stronger here compared to that of the tetrahedral complex. Also the geometry comes into the picture. So those things you roughly keep it in mind for getting into the next area, that is area of interest. Next one is the tetrahedral complex. So is it clear about the octahedral complex? I'll just put it across like this, students. So we have seen this chromium, water, 6 times, 2 plus we have taken, chromium ammonia 6 times, 2 plus. This we had written T2G4 Eg0, whereas this is T2G3 Eg1. Why we had written so? Because the ligand is important here. This is a strong field ligand. Right, and this is a weak field ligand. Since it is a weak field ligand, delta naught is less than pairing energy, electron will go to the higher energy level. Whereas in this case, delta naught is greater than pairing energy, electron will be positioned in the lower energy orbital. Very clear? So we will take few more representative examples regarding the CFSE calculation, then we will switch over to the tetrahedral complex. K4FeCN6. K4FeCN6, one complex. K4FeCN6 we will take it, and K4, not K4, FeCl6, FeCl6, negatively charged one, K3 FeCl6. We will take it. So can we speak about can we calculate the CFSE for this? So this is Fe in the +2 state, students, because 4 plus 4 ion, K plus ions, 4 minus, so you will be having Fe in the +2 state. That is, ion is in 26 atomic number, 3d6 4s2, 2 electrons we have removed, that means 3d6 configuration. That is, it is a d6 configuration. Since it is a d6 configuration, let us start filling it, because anyhow both are octahedral complex. Let us start filling it. 1, 2 and 3. Now you have 6 electrons. Either the 4th electron can go here or else it can pair over here. But it will not go up, rather it will start pairing, because the ligand is a strong ligand. Got it right? What does the strong ligand means? Strong ligand means it will split very high. That is, delta naught will be very high when the ligand is stronger. That means it comes very close to the central metal ion. When it comes very close to the central metal ion, what it means? It means that the overlap between the d orbital, the interaction between the d orbital and that of the ligand electron will be very high, or in other words, the repulsion will be higher, or in other words, the splitting will be very high. When the splitting turns out to be higher, what happens is delta naught will be very high. Electron cannot jump up, rather it will start pairing. It will start pairing. That means how many electrons we will be having? 6 electron. 6 electron gets paired. 6 electron gets paired. When it gets paired, how do you write the CFSE? 6 into minus 0.4 delta naught. That means minus 1.2 delta naught. Sorry, minus 2.4 delta naught, highest delta naught it is having, or in other words it is having minus 24 dq is the CFSE for this. CFSE for this is minus 24 dq. Minus 24 dq. Whereas the CFSE for this is, let us quickly calculate, students. This is a plus 3 complex, Fe plus 3. That means D5 system. How many electrons you are having? 5 electrons. 5 electrons, I will just put it like this. 1, 2, 3. Fourth electron will go here. Fifth electron will also position here. Why? The ligand is weak ligand. Halide ion ligand is a weak ligand. It will position up. That means 3 into minus 0.4 delta naught plus 2 into plus 0.6 delta naught. That means 3 into minus 0.4 minus 1.2 plus 1.2, the delta naught, that is CFSE for this complex is 0. They may ask you which of the following complex is having 0 CFSE. This complex is having 0 CFSE. Don't have to by heart, keep it in mind, very simple.